Hi everybody, my name is Jim with Full Moon Adventure Club, and today we're going to be doing a review on this 3000 watt pure sine wave inverter, as well as a 60 amp DC to DC battery charger from LEAPTREND. These were sent to me for free to do a review video on, so we're going to put them through a bunch of tests. I'm going to show you what they're used for and how you would set them up in your RV or your truck camper or your off-grid situation, and we'll kind of put them through the test and we can see if these are right for you. If they are, there's a link in the description below that will take you over to their website, and they help support my channel when you use that link if you end up being interested. So why don't we get right into putting these through the test. We'll do the unboxing video. I'll go over what's included and what's on the units themselves, and then we'll go into how to hook them up and see how they did. So let's jump right into it. So what we have in the DC to DC charger box is the manual, our warranty card, and the charger itself. Pretty straightforward, well packaged, not a lot to it. The inverter comes with this nice reusable box, which I think is pretty cool. And then inside we're going to have our manual, warranty card, your remote control, 20 foot of cabling, and then the inverter itself. Again, well packaged, not a lot to it. Now both the charger and the inverter have a wide range of applications, from camping, boating, RVing, etc., off-grid houses. This is a breakdown of what the charger does. So you're going to have your main vehicle battery or your chassis battery in the front. That's going to be powered by your alternator and recharged. And then you're going to connect that to the DC to DC charger. And what that's going to do is two things. Below that is going to be your auxiliary battery or your coach battery. That's going to run all your stuff at night. So your lights and all that things while the engine's not running. What the DC to DC charger is going to do is two things. It's going to first of all isolate the auxiliary battery so that when it's being drained at night, it is not taking power from your starting battery up front. So that's going to be full charged, ready to start your engine in the morning, and it won't get drained with everything else. Okay, now when you actually go to start your engine in the morning and you start that up and it receives signal that the engine is running, now it's going to allow power to go through that charger and fill up your auxiliary battery. Now the second thing that the DC to DC charger does is it doesn't just allow power to go straight through it. It actually has a 3-stage charge profile that's going to charge your battery at the correct speed to the correct voltage, depending on the settings that you have set on the DC charger itself. So it kind of has a dual purpose there as a battery isolator and a battery charger for multiple battery types, which is very cool. Now you're going to have multiple settings here on the back of the DC to DC charger. Now it can charge lithium iron phosphate batteries, gel batteries, lithium batteries, deep cycle batteries, and AGM batteries. And depending on where you set that is going to change the charging profile as well as the overall top-off voltage where it's going to stop charging the battery. And you'll have to basically just look at the manual to see what those voltages are. And we'll be doing an experiment later where we test the lithium iron phosphate voltage cutoff. So the smart 3-stage charging, depending on what battery setting you have it on, is going to include a bulk charge, a boost charge, and also float charge. The unit itself weighs 6.6 pounds and its dimensions are 12.32 inches in length, 7.40 inches in width, and 3.11 inches tall. It does have over temperature protection, reverse polarity protection, and over voltage protection, which is handy just to make sure that everything keeps from getting damaged in case you make a mistake in the setup. Now on to the inverter. This is a 3000 watt pure sine wave inverter with a 6000 watt peak. It is 18.7 inches in length, 4 inches tall, and 9.3 inches wide. It does come with the remote control and about 20 feet of cabling for that remote control, and it does come in at 12.5 pounds. So the front of the unit does have a really nice LCD screen. We'll get into that a little more here in a second. 3 AC outlets, a high output AC terminal there so you can actually connect Romex directly to that, run it through conduit to a breaker panel box or anything like that if you're doing an off-grid cabin type situation or anything like that. You do have your GFCI LED that indicates when there was a fault and it did trip that circuit, and it's going to automatically reset itself after a certain amount of time. You're also going to have your USB port located there. That is a 3 amp. Your remote switch connection is located down there at the bottom. You can run that out the 20 feet of cable and put that remote control switch anywhere you want. The on-off switch is located here, and when it's in the up position, the inverter is just on. When it's in the middle, the inverter is off. And when it's on the lower switch, it's going to be controlled by the remote control switch. On the back of the unit, it's pretty simple. You're going to have your positive connection underneath that plastic protective cap right there. You just squeeze that and it pops right off. Screw in terminals there. You can attach your cables and then make sure you slide that protective covering over the cable before you connect it. Then you can slide that right into place and clamp it on. That's going to protect the terminal from accidentally making contact with anything metal. You're going to have 2 cooling fans and then your negative on the other side. It also comes equipped with a grounding screw right here, so you can actually run a ground from the inverter to the chassis of the vehicle to give it an actual ground. I absolutely love this display. You have the battery, a little battery indicator up top, the DC voltage of the battery, the AC voltage coming out, the wattage being used, whether or not the fan's on, 60 hertz, and that bar at the bottom is going to let you know how much power you're using. So you see you increase the wattage, it's going to let you know how much more of the capacity you have, and if you go too far, it's going to tell you that you overloaded and go into protection mode. So really cool display there with lots of information. The wiring I'm using for this experiment is a 1/0 gauge welding cable. It's stranded pure copper, and you can see, for example, on the left is a 2-gauge wire that you would typically see maybe going to the car battery in your car, where the one on the right is actually that 1/0 gauge stranded copper cable. It is huge, and that's probably good for 3,000 watts at about 8 feet, but you need to do your own research, and depending on your setup, you may need bigger wire than that, depending on how far you're running it. This is the basic setup that you would see in the RV. So I have basically the chassis battery and the alternator connected up top. That's going to go to the DC to DC charger. That's going to go to your auxiliary battery. That's going to power your inverter, and your inverter is going to power your AC appliances. So why don't we take a look at this a little bit closer so you know what I'm talking about. So these aren't even big enough wires by a long shot. I'm using jumper cables for this experiment, but red is connected to the positive terminal of the battery. Black is connected to the negative terminal of the battery. And then as we go down to the DC, that's going to go through the walls, into the back, or wherever you want to your DC charger. And here you can see red is going to go to positive, black is going to go to the negative input, and then on the other side, same thing. You're going to have red positive going out to your auxiliary battery, and black negative going out to your auxiliary battery, and connected in that same fashion. Now there's also this wire that you're going to have to wire into your vehicle's ignition, so that when your engine is started and your ignition is on, that's what's going to tell the DC to DC charger that it's time to charge that other battery. In this experiment, I'm going to be replicating that with this toggle switch, but that's important because otherwise you'll drain your battery and it'll leave you stranded. So it does need to be wired into your ignition, into the on position, so that it only kicks on when your engine is running. Now we're going to have our 2 wires coming off of our auxiliary battery going to the 3,000 watt inverter, and then that's going to get its power, and as soon as you turn that on, it's going to power whatever AC appliances you want, your breaker panel, your cabin, your RV, whatever. So that's the basic setup, but one of the really important things that you can't forget is you're going to need a really big couple of basic fuses in here, and they're probably going to be about 300 amp fuses, and they need to be close to each battery on the positive terminals, both terminals. So you're probably going to need 3 in this particular setup, because you do want to make sure that you have fuses right by the battery going out on the positive side at all locations. Okay, so don't forget that. You're definitely going to need fuses. Size them correctly for your wiring. Okay, so now I want to do a practical application to actually measure the amperage coming off of the battery. So I'm using this amp meter here, which has small wires, so I can only do this test for a minute. Now the engine is started and it's at idle. And as you can see here, we're pulling 45 amps from the battery going to the DC to DC charger. And so it does seem to sense when the engine is at idle and there's less current, so it's not going to drain your battery. It was taking as much as the alternator was putting out at idle. So now I'm going to wedge a stick against the gas pedal, take it up to about 3,000 RPMs. So the engine's actually revving. Now we're going to try it again. You can see our battery voltage go up when I turn this on. And also we're pulling 80 amps from the battery to the DC to DC charger. So it can sense the available current and it does adjust accordingly. It usually pulls about 75 amps for the first 10 minutes, then it kind of settles into 60. And the current going from the DC to DC charger to the battery is always at about 56 amps until the battery's almost charged. So I hope that's a good little indication of how this is all kind of set up in your vehicle. It goes from the chassis battery to the charger, to your auxiliary battery, to the inverter, and then to your AC appliances. And that's all it is. So let's jump inside and do some tests with a more controlled environment. Okay, so right now LEAPTREND is that 3,000 watt pure sine wave inverter is running my entire basement here, which is a lot of stuff. It's a bit of a mess right now, but lots of LEDs, lots of lights, lots of computers. So definitely trusting the pure sine wave here. What we're gonna see here is that we're using 360 watts right now to run all this stuff down here. And that's all coming off of this Lion Energy lithium iron phosphate battery. And later, once it's drained, we're gonna use those two big guys from Big Battery to act as the alternator and house batteries and stuff like that. So what we're gonna do, since we are using 361 watts right now, that's gonna take a long time. We're gonna hook up this little space heater, and as I turn this guy on, we're gonna see this go up. So now we're using 1,600 watts, or 1.6 kilowatts. And so now we're gonna let that run. We're gonna let it drain this battery down a little bit. You can see it's fully charged. And we're gonna go from there. So we'll set this down. Let that do its thing. And then we'll test out the DC to DC inverter and check the voltage on that battery. All right, so now that our battery is down to 60% according to the little onboard battery display there, we're gonna go ahead and turn the inverter off, disconnecting the whole basement here. And we're gonna check the voltage on the battery, and it is at 12.04 volts. And in case you guys were wondering, the standby voltage with the inverter on but nothing plugged in ends up being 0.58 amps. So about a half an amp, which is actually really good. All right, so the DC to DC charger is hooked up. You can see here we're pulling 80 amps, which is pretty typical for the first 10 minutes until it settles in. 80 amps being drawn. I also double checked this after 5 minutes with my amp meter. 73 amps coming out of our chassis battery or alternator source. And what we were charging the battery with was 57 amps. And that was pretty typical with my testing. About 56 to 57 amps being put into the auxiliary battery. The auxiliary battery is at 60% charge according to its onboard meter there. And after about 10 minutes, you can see it settled into about 62 amps being drawn from our chassis battery and alternator source. Now right here on the left on the green voltmeter, that's our auxiliary battery. It's at 13.4 volts. And then the two big batteries are acting as our alternator chassis battery source, and they're at 13 volts. So if this was direct across, we would never be able to charge our auxiliary battery past 13 volts. But you can see, since it's saying 13.5, that it is working to step up that voltage. And I also connected my red amp meter on the very left, and you can see we're like 50 amps, and then we go to 40, and then we're going down to 35. So it is stepping down the voltage as we get closer to being fully charged. And what it's set at is 13.8 volts. Is fully charged. I'd like to see that higher, up to almost 14.3 to 14.6, but they have the DC to DC charger set to stop at 13.8 volts, which is kind of a middle of the road safe zone for a lot of lithium iron phosphate batteries. But we'll talk more about that. I spoke with LEAPTREND, and I'll tell you more about what they said about that voltage at the end of this next experiment, where we really put the inverter through the test and push it way over the top with a lot of power. So let's go check that out real quick, and then I'll be back with you about what they said. And you will notice that the battery itself did say it was charged to 100% according to its onboard battery meter. So there is that. But more about that in a minute. We're going to turn this guy on. And then we're going to turn this up. All the way on high. It's showing that we're at about 1,600 watts, and now we're going to crank this guy up on low first. And now we're going to try it on high. It says we're at 2,200 watts. Here we go. Oh, what the heck? Let's just push it completely over the top, shall we? We got a third plug. Let's use it. Okay, here we go. This is ridiculous, but we're going to turn this to high. Turn this guy to low. Pulling 2,200 watts. Let's see if we can turn on high. 2,800 watts. Okay. There we go. It kicked back on, so it did protect itself, and it did come right back on. But that was at 3,000 watts, and then we did the skill saw. So with this guy running, no problem. But on high, that thing is a definite beast. That is a crazy, crazy inverter. 3,000 watts is a lot of power. Well, there you go, guys. If you want a really technical under the hood look at this, I found a really well done video by Electronics and More. I'll put a link to his channel over there to this video that covered this particular inverter. And he really dives deep as far as an oscilloscope and the waveforms and all that. If you want to get real technical, I'll send you over to him because he did a good job, and that keeps my video length a little bit shorter. In my practical applications, everything did really well. Pros and cons. Now, with the DC to DC charger, the 60 amp, I would like to see a higher charge voltage for the lithium iron phosphate setting, and on this particular model, it capped out at 13.8 volts. And when I contacted LEAPTREND about that, they said that's kind of a safe, middle-of-the-road voltage for a wide array of different battery manufacturers, so they're kind of playing it safe with that. And even though my lithium iron phosphate battery does have a little battery gauge on it, and it did say 100%, I suspect it was probably at around 95, somewhere in there, because we didn't get to the full 14.6 volts, and they said that'll help your batteries last longer and blah, 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 and it's true, but also I'd like to see a little switch or something that can bump that voltage up. They said if you'd like to get a fuller charge out of your battery, you can switch to AGM, which has a similar charge profile and will take the cutoff voltage to 14.2 volts. So I just wanted to share that with you. Also, on the battery alternator side coming into the DC to DC charger, that typically pulled 75 to 80 amps for a little while until the battery started to get charged. So you're going to want to keep that in mind when you size your cables for that side of the DC to DC charger. What came out of the DC to DC charger going to your house battery was 56 to 60 amps, and so you can use that to size your cabling going down. And I would recommend you use the right size cabling, which is thick for 12 volts, and also maybe getting a dual output alternator so that you're not overworking your factory alternator by charging two batteries at a very high rate. But that's kind of standard when you're going to be charging batteries, off your alternator. It's probably good to upgrade. Now, other than that, the DC to DC charger did exactly what it was supposed to do and worked quite well. Now, the 3,000 watt inverter, I have no problems with whatsoever. It's an absolute beast. 3,000 watts is a lot of power. That's enough to run two 15,000 BTU rooftop air conditioners at the same time, probably. And or two 1,500 watt space heaters, which is similar to the test that I ran them through, including the circular saw, which was quite impressive. It's just a lot of power, and considering the price point, that makes this a pretty interesting purchase, so you might want to check it out. Other than that, I really like the 3 outlets that they have on there. They are GFCI protected, which is a good safety feature. They do have a USB that's 3 amps on there. That's great. The 20 feet of cable with the remote on-off switch is very handy to be able to turn it on and off. I like that they include that as well. And I like the color scheme, the build quality. I think it's pretty handy. I'm actually probably going to be using that for my pump room, running two really high surge shallow well jet pumps for my water system, because that inverter is going to handle that no problem. So if you need a lot of power for your RV or your truck camper, travel trailer, or your off-grid cabin setup, I think this is a pretty interesting unit, and I've had no problems with it with all my testing. if I ever do run into problems with these guys over the years of me using them and putting them through different tasks around the house, if anything ever does go wrong with them, I will update my description down below to reflect that. So you can always check the description to see if it's still holding up over the years. If you are interested in something like this, I will put a link down below that'll take you over to their website. It's an affiliate link, so that does support my channel, but if you're interested, click the link down below. It'll take you straight over to them. I think that about wraps it up. So far, so good with these guys. Really like them, and I'm going to be putting them to work. So I hope that helps you out in making your decision. My name is Jim with Full Moon Adventure Club, and until the next video, thank you so much for watching, and happy camping.